Born from the fiery chaos of the Big Bang almost 14 billion years ago, our universe is a tapestry of unimaginable forces, desperate struggles, and astonishing mysteries. For eons, observers have gazed at the night sky, drawn in by the immense vastness beyond our world, wondering how it all began, and how it might end. At the heart of this cosmic narrative, two invisible titans wage a relentless war, each vying for ultimate control over the universe's destiny, matter and dark energy. Their conflict is silent and nearly unfathomable to our senses, but it will decide how everything we know, every star, planet, and atom, will meet its final fate. On one side stands matter, the tangible building blocks of galaxies, stars, planets, and the enigmatic substance known as dark matter. Though vastly different in their forms and origins, all matter shares a fundamental trait: an irresistible urge to come together. Bound by gravity, matter clusters and compresses, forming galaxies and grand structures on scales too vast to comprehend. Gravity's pull is painstakingly slow but inexorable. Even as the universe has expanded over billions of years, gravity has kept matter tight-knit, forging stars and galaxies from the primordial fog of creation. Yet, the universe is not static. Since the moment of the Big Bang, space itself has been stretching, causing galaxies to drift apart from one another. And as the cosmos grows, a second warrior enters the fray, a far more elusive force whose origins remain shrouded in mystery. This is the story of empty space, or more precisely, the energy embedded within it. Dark energy. To the human mind, empty space seems like nothing at all. But physicists have learned that even the most profound void contains a kind of energy. An energy that appears as if from nowhere, filling the vacuum and exerting a force all its own. We do not know what dark energy is or why it exists, only that its presence is felt on the grandest scales imaginable. It stretches space apart, acting as a sort of anti-gravity, accelerating the expansion of the universe rather than merely letting it coast. And so an epic duel unfolds. Matter clings together, fighting to keep galaxies whole, to forge bonds and counteract the universe's expansion. Dark energy, relentless and invisible, pushes outward, urging space to grow, scattering matter across ever greater distances. The balance of power between these two forces will ultimately decide the fate of all existence. What lies ahead for the cosmos? Much hinges on the future behavior of dark energy, something scientists can only guess at for now. Yet by considering a few profound possibilities, we catch glimpses of both wondrous and terrifying destinies. Imagine first that dark energy's strength remains constant, always pushing, always accelerating. In this scenario, dark energy will eventually overwhelm gravity on nearly every scale. Vast swaths of empty space open up between galaxies, and as the universe grows, the matter within it becomes ever more diffuse, like sugar dissolving in an inexhaustibly growing cup of tea. This relentless expansion sets off a feedback loop. More space brings more dark energy, which in turn pushes galaxies further apart at an ever faster pace. Over trillions of years, island galaxies caught within local neighborhoods continue merging, forming supergalaxies filled with trillions of fading stars. But these clusters, too, are isolated by the growing rift of cosmic expansion. Eventually, only darkness remains outside their bounds. One by one, the lights go out. Stars burn their fuel and die, stellar remnants cool into oblivion, and even black holes evaporate over inconceivably long eras. Each remaining trace of structure dissolves, leaving a universe of utter loneliness, featureless, cold, and lifeless. The expansion never ceases, and the cosmos is left in an eternal, unchanging heat death. This is the Big Freeze, where not even the faintest glimmer of activity will ever return. And each remaining particle, adrift in infinite darkness, is as isolated as if it were the only thing to ever exist. But what if dark energy is not content to simply remain constant? What if it grows ever stronger over time, its grip tightening with every epoch? In such a universe, dark energy's power escalates, overwhelming all resistance with increasing force. The expansion accelerates to a degree that cannot be matched by any form of matter or gravity. First, galaxies themselves are torn from one another. Over the next billion years, stars within galaxies are forced apart. Then star systems themselves are shredded, planets flung from their orbits, lost to the cold embrace of deep space. A few million years later, the very fabric of matter begins to unravel. Atoms are ripped apart, electrons and nuclei separated in the creation of new, all-consuming space. Black holes, once invincible, shrink to nothing and evaporate in explosive bursts. In a final apocalyptic instant, the fabric of reality itself is undone. Time and space lose their meaning in what is known as the Big Rip, a catastrophic event where even the laws of physics fall apart. What comes after, no one can say. But if these scenarios seem bleak, consider a cosmic twist of fate. Imagine dark energy fading, its strength ebbing away over countless ages. As its influence wanes, gravity may begin to reclaim its dominance. The expansion of the universe slows, then halts, and finally reverses. Galaxies draw closer, clusters collide and merge. The universe itself contracts, not explodes outward, but implodes. Space becomes hotter and denser, bathed in the radiation released from countless eons of stellar activity. Eventually, all matter coalesces into a singular blazing point, the Big Crunch. Whether this marks a final annihilation or the rebirth of a new cosmos in a cyclical dance is unknown. Perhaps the universe will bounce back, beginning again in a fresh act of cosmic creation. Or perhaps all will end in a silent singularity. Scientists search for answers in distant supernovae, in the faint afterglow of the Big Bang, and the quivering patterns of cosmic background radiation. For now, evidence suggests we are heading toward the slow, cold fade into heat death, as dark energy holds sway. Yet the true fate of the universe remains one of the deepest and grandest mysteries. So as we look to the stars, we acknowledge the struggle of matter and dark energy, a struggle that will continue long after our own brief flicker of life has passed. And if the universe grants us trillions or even quadrillions of years, we have time to marvel, to explore, perhaps to adapt and persist, making the most of our fleeting window in the cosmic story. The ending has not been written. For now, the greatest adventure is simply to witness, to wonder, and to treasure the universe we call home. Did you find our videos helpful? Please like and subscribe to our channel so we can be motivated to answer the questions that people are still wondering about.